Welcome everybody. Today we're going to be diving into retention on your installs. And as you know, within the mobile games industry, it's standard practice to compute day 1, day 3, day 7 retention. I'm going to show you how to build a dynamic query so that you can pull retention by X days. Again, we're going to be replicating the analysis behind me, which shows day X retention for installs beginning at day 1 retention and going all the way up to day 15 retention, and including all the values in between so that you can successfully answer any question you get regarding your installs and their retention percentages. So let's go ahead and move over to MySQL and I'll show you how to do this for your own business. Okay, so we're just going to start with a customer logins table. So let's preview a few records together. And it's just each customer and their unique login dates. Okay, great. So now there are a couple of things we need to do. So let's grab the customer ID since we're going to need this. And then let's identify the install date. So what we're going to do is use a window function here and say min login date over, and we want this by customer ID. So partition by customer ID. So for each customer ID, it's going to select the very first login date, which we will call the install date. And then a very important aspect of computing retention is identifying the date that your data is through. Because, for example, if someone installed yesterday, we don't have enough data to compute their day 7 retention. So we need to know when to stop computing retention because we simply don't have enough leading data. So to do this, what we're going to do is identify the date that our data is through. So we're going to do the max login date, not per customer, but across all records in this SQL table. So over absolutely nothing. Call this date, data through. And the date of this recording is January 24th, 2025. So the date that our data is through the prior day. So January 23rd, 2025. Let's run a few records. Okay, great. So the date that our data is through the prior day. So January 23rd, 2025. And then here's the install date per customer. Now, before we move on, what I would recommend is let's declare a variable here at the top of the script to ensure that this script is dynamic, meaning we can change it. So let's declare a variable called set retention days equal to 15. What this means is for this script, we want to be able to compute retention for day 1, day 2, day 3, all the way up to 15. But we can change this to 7, we can change this to 30. So let's just do 15 now, but realizing that we can reference this and change this value to do a different number of X days from install retention. Okay, let's take this beginning part of our query and wrap it in a subselect. We'll call this installs. Okay. And now let's bring up our fields from the previous subselect, making sure we add the installs prefix. so that it knows to retrieve this customer ID field from the installs subselect. Okay, so here's what we're going to do next. To calculate retention, we need to bring in leading dates from the install date. So if a player installed January 1st, 2025, we need to bring in the leading dates in January and see if they logged in on those leading dates to calculate that retention percentage. So we have a table of dates, it's called dim date. And within that table, in our second column, we have a column of dates. So let's do a left join over to this date table, which we'll rename to dates on the date column. Second column from the dates table has to be greater than the install date. So why does it have to be greater than the install date? So returning to our example, if someone installed January 1st, 2025, we want to calculate day one retention. The very first thing we want to calculate is day one retention. And day one is always going to be the install date plus 1 day. So because of that, we want the leading date value to be greater than the install date. If we did greater than or equal to, it would bring across the install date again, and we would be calculating day 0 retention, which doesn't exist because it would always be 100% since it equals the install date. Okay, so we'll change this back to date being greater than the install date, and the leading date value or date from this second table has to be less than or equal to us adding 15 days, 15 leading days through this variable that we declared up here, enabling us to calculate day 1 through day 15 retention. So if we look at this again, at a minimum, the first retention value we want to calculate is day 1 retention, and that's the install date plus 1. So because of that, we're asking that the date from the second table that we're bringing across has to be greater than the install date. It cannot be greater than or equal to the install date, because if it did, we would be calculating retention on the install date, and since they installed and logged in on that date, the ratio would be 100% and it wouldn't be useful to the business. So we're going to start with day 1 retention. So date is greater than install date, and then we want the date from table 2 to be less than or equal to us adding 15 days to the install date via this variable that we declared up here. So that'll allow us to calculate retention for the leading 15 days from the install date, assuming that those leading dates are less than or equal to the date that our data is through. That's a very important point and part of the overall retention logic. Okay, wonderful. Let's go ahead and bring these leading date values across. We will rename this to leading dates so it makes sense. And then let's also add a calculation. We'll do a difference in days, date diff between the leading date value and the install date. Call this days since install. And then the other thing that's super important is we have to make sure that of the 15 leading dates from the install date that we're bringing across, all of those days have to be less than or equal to the date that our data is through, which in this case is January 23rd, 2025. If we have a leading date value that's in the future, call it February 1st, 2025, we can't calculate retention for that leading date because that data does not exist yet. So we will do where these leading dates are less than or equal to the installs dot date our data is through. Okay, let's run a few records. Okay, wonderful. Here's a sample 100 records from our query. And as you can see, everything worked. We have our customer, we have their install date, and we have the leading 15 days after their install date, as long as those leading dates are less than or equal to the date that our data is through. And then we have a helper column here, which is just indicating the days since install. Now, what I want to do is do something for our own convenience and create a 6 column, which is just going to say day 1 retention, day 2 retention, day 3 retention, etc., etc. So let's do that. It'll just make things a lot easier when we move this over downstream to Excel. So let's concat day since install, and then we will do another concat call this retention day, and let's see what we get. Let's rerun our query to view a random 100 records. Okay, great. So you see this new column here, which shows day 10 retention, day 9 retention, day 8 retention. This is just going to help us now that we have the exact values we need for the x-axis in the analysis we looked at earlier in this tutorial. Okay, so the next thing we need to do is for each of these customers, we need to join on customer and leading date value over to our logins table to see, did they actually retain? Did they actually log in on one, none, or all of these leading date values after install so that we can calculate their retention? So again, we have this data, which is customer ID, install date, and then those leading and different date values, and we need to join on customer ID and leading date value over to our logins table on customer ID and login date to check to see if they logged in on these leading dates. And if they did, then they retained, and if they didn't, then they did not retain. Let's call all of this customers. And now we're going to join over to this table right here. We saw it earlier in this tutorial, but I'll show you again. It is our logins table. So for each customer, we have their login dates. So let's go ahead and join back to that table. We will call this logins, and we will join on customers.customer ID equals logins.customer ID. And then the customers.leading date has to be equal to the logins.login date. So what this join is doing is it's searching for a match on this customer and this leading date. And if it finds a match, this will be populated. This date will equal this leading date value. So with that, we're going to take this and say case when the login date from table 2 is successfully brought across with a populated value, so is not null, then 1, else 0, end. And we can just call this retention flag. So we don't need to do any aggregations because the granularity between this subselect and this table 2 is the same, right? In our first table, it's customer and the leading dates, and in our second table, it's the customer and the login dates. So we're joining on customer ID, and on the leading date is equal to the login date. If there's a match and the login date value is not null, then they logged in on that leading date value, meaning they retained. So then 1, else 0, and we're calling this the retention flag. Okay. So all we need to do now is aggregate this data. We code our subselect final, so we'll do final dot. We don't need the customer ID, the install date. We do need the retention day. That'll say day 1, day 3, day 8 retention. That'll be on the x-axis. And just do a count and just call this installs, and then we can just take this retention flag and sum it. We can call this, I've never seen this plural, but we can just call this retentions because that's what it is. And there is one other thing I want to bring in, and that's going to be the day since install, because this is a number and this is text, and when we take this over to Excel, we want to sort by this number so that we can get everything in the correct order on the x-axis in our chart. Okay, let's aggregate this data. Okay, here is our query in its entirety. Let's go ahead and run it. Okay, everyone. Since we were running this query for all installs live to date for this demo online business, that's about 2 years of data. So it's a pretty intensive query. So let's work together to actually slim down this query and make it easier for MySQL to execute. So let's zoom in a little bit. And here's what we're going to do. We're going to remove a few of the columns in these subselects that are not needed. So if we look up here, we need day since install. So we're going to keep that. We're going to keep retention day. And then we're going to keep the retention flag, which is right there. So if we check it again, we're going to keep day since install. We're going to keep retention day. And we're going to keep the retention flag. So we're going to remove leading dates. We're still going to use it in our join down here, but we're going to remove it. And then we don't need the customer ID, the install date, or the date that our data is through. So that's great. It dramatically reduces the number of columns that MySQL has to return. So let's go ahead and try running this query again. Okay, everybody, let's continue to optimize this query just a little more. So these two columns right here, install date and date data through, are not going to be needed because we've already used them in previous steps. So date the data was through was used down here, and the install date we just needed to bring across those leading 15 days of data. So since we have that, we can remove those two columns from here and see if that makes an impact on our query performance. So let's rerun our variable and try this again. Okay, everybody. So we've optimized by removing some unnecessary columns in the select statement. Let's do something else, and I'll teach you a trick so that if you in your own lives are running into issues where the query you're running is taking up too many resources and isn't running to completion, what you can try is what we're going to attempt next, which is to create a table and have all of these records from this query inserted into that table so that MySQL doesn't have to return a huge data set. So we're going to do create table, and it's going to be in our same mobile games database, and we'll call it retention X days from install. And then what you want to do is you want to define the column names and the data types. So it'll be days since install, and that's going to be an int. And it'll be retention day, and that's going to be a string of varchar 255. And then installs is just going to be another int. And then retentions is just going to be another int. So let's go ahead and create this table. Fantastic. So I'll show you that we successfully created this table. And there it is. We have the column names, but no data. So let's go ahead and insert the records into this table we just created. So we will say insert into the table we just created with these field names, right? Day since install, retention day, installs, and retentions. Okay, great. Now let's go ahead and take this query and take the records that result from this query and have them inserted into this table. So select all of this and just run it. Okay, everybody. So to recap, this is a pretty large query, and what we have done to optimize it so far has been to remove some unnecessary columns in the select statements and also created a table so that we are not returning the entire result set, but instead inserting records into that created table. Now, since my version of MySQL is still having difficulty running this query, here's what we're going to do next. So we have some pretty intense joins going on in this query. So what we're going to do is put indexes on the fields in these tables that we're joining between. So up here, just going to paste this. And I'm going to change this to index. I want to make it a little more readable for us. So as you can see, we're going to go to fact player logins and we're going to put an index on the customer ID column and also on the login date. And then on dim date, we're going to put an index on the date column or the second column in that table. And then we're also going to create an additional index on both customer ID and install date on the fact player logins table. So let's go ahead and run these statements. Okay, so of the 4 indexes, you're able to add the second one up here. So just an index on the login date from fact player logins. So let's go ahead and make sure that our table is empty or cleared out. So truncated. And if it is, then we can begin to run our insertion statement. So it is, that's fantastic, great. Now let's go ahead and run this insertion and see if we have any luck. Okay, so to update everyone, the last thing we did was we added an index on one field and on one table. And it was creating an index on the login date column in fact player logins. So these other indexes on these other tables unfortunately didn't work, likely due to the settings on the tables and or the table schema. But let's try one more thing as we continue to optimize this query. So what we're going to do now is let's just turn this case statement into an aggregate function and just say when the login date is not null than 1 else 0 end, and then we'll just take a max of that value. And let's add a group by. And once again, let's ensure that there are no records in this table. And once we confirm that, we can just run the insertion statement again. So we can run the insert statement now and see if this latest round of optimizations works for us. Okay, everybody, we've finally gotten our data set, but just to review what we did one last time, we optimized the query by removing a few columns that were unnecessary in the select statement. We needed them in the joins as join keys, but we didn't really need them in the select statement, so we removed them. In addition to that, we also created a table. So instead of returning the entire data set, we inserted the records into this table that we created called retention x days from install, and then ran the query so that the results would get inserted into this table. And then in addition to that, we created an index on a field in fact player logins login date to make this join down here a little bit faster. The very last thing we did, which is completely unnecessary, was to change this case statement by turning it into an aggregate function and putting a max here and then grouping by these two fields. That last part I wouldn't recommend doing. It's just something that we tried and it appeared to work. The reason why I wouldn't recommend doing it is because the granularity between these two tables is actually exactly the same on the customer login date, customer leading date granularity. So again, both of those tables have the same granularity defined as customer and day. So this group by and this aggregate function isn't necessary. Well, anyway, after all these optimizations, we were finally able to get our data. So let's move over to Excel and finish up this analysis. Okay, so here we are in Excel, and all we need to do is basically just calculate retention. So retention percent. And that's just going to be the retentions divided by the installs. And recall we created this column days since install so that we can sort this data. So we will go here, we will go to sort, days since install. Great. I'm going to rename this to retention day, but capitalize the first letter of each word. And then let's turn that into a percentage here. Wonderful. Okay, so let's add our data labels. Let's format this a little more. Let's add a border, solid black. Fantastic, everybody. So together we wrote a dynamic query where we can return the retention for installs by X days from their install date. And in this instance, we made the value in our variable 15 days. So we looked at day 1 through day 15 retention with all the days in between. And again, we wrote the query dynamically. So all you need to do is just change the value in the variable and it will change the output. This is super valuable information because not only do you get the very standard day 1, day 3, day 7 retention values that a lot of ad partners use, but you also get day 6 retention, day 11 retention, day 14 retention, and so on and so forth. And it's pretty cool because it creates a waterfall for your installs and gives you insight into how long they retain by X days from their installation date. I hope this tutorial was helpful. Have a wonderful rest of your day.